Hello, welcome back. Today we're going to look at question number 2 from the 2005 AP Calculus AB free response section. So let's look at it. The tide removes sand, so that's important information. We should look at that. The tide removes sand, so this first equation, R of t, is the rate at which it removes sand. The tide removes sand from Sandy Point Beach at a rate modeled by the function r, given by R of t equals 2 plus 5 sine of 4 pi t over 25. And then it says a pumping station adds sand, so that's important. This is the function that tells us how quickly it's adding sand. So a pumping station adds sand to the beach at a rate modeled by the function s, given by s of t equals 15t over 1 plus 3t. It says both r of t and s of t have units of cubic yards per hour, and t is measured in hours for t is between 0 and 6. At time t equals 0, the beach contains 2,500 cubic yards of sand, so that's also going to be important. So this is a calculator active problem. So the first thing we should do before we even read the questions is get these functions in our calculator so we're ready to graph them or evaluate them at different points. So I already put the functions in. So we have y1 is r of t, or the rate at which sand is removed from the beach. So this is y1. And then down here, the rate at which sand is being added to the beach is y2. So A asks, how much sand will the tide remove from the beach during this 6-hour period? Indicate units of measure. Okay, so let's look at A. If sand is removed from the beach at a rate modeled by this equation here, then to find the total amount of sand that is removed from the beach between 0 and 6, time equals 0 and 6, what we have to do is find the integral between 0 and 6 of r of t with respect to t. So now we can go into our calculator. Second quit, and then we go math 9. So now we have the integral. We type in 0 to 6 because that's our interval, and it's asking how much sand will the tide remove. So we're doing y1, which is r of t. So we do alpha trace 1 and then x, because in this case we use x because we're not going to use t on the calculator, we're going to use x. So now we have this, and we just click enter, and it gives us our answer. So during the first 6 hours, 31.816, you can truncate or round, meaning you can write 815 or 816, but we'll do 816. So during the first 6 hours, 31.816 cubic yards of sand were removed from the beach, because it says both r of t and s of t have units of cubic yards per hour. So if this is cubic yards per hour and we're taking the antiderivative, so we're moving back instead of differentiating, it's going to go from cubic yards per hour to just cubic yards. So now we can move on to B. I'm going to just erase A so that we have more space to work on B. And B asks us to write an expression for y of t, the total number of cubic yards of sand on the beach at time t. So we need to make a function that models how many cubic yards of sand are on the beach at any time t. So we're going to have to use integrals again, remember, because integrals give us the total amount of sand for each function. So first, with any question like this, we have to see what it is how much sand there is at time t equals 0. So at t equals 0, the beach contains 2,500 cubic yards of sand. So let's start by going like this. B. We're going to have y of t is equal to 2,500 plus, right? Because we have 2,500 cubic yards of sand to start out. And then what we're going to want to do next is add the integral from 0 to t, right? Because it's the total number of cubic yards of sand on the beach at any time t. So 0 to t of s, we'll write s of x, because so now we're adding the starting amount plus the total amount of sand added to the beach. Make sure you write dx. And then we're going to be subtracting the integral from 0 to t of r of x with respect to x, because what this integral represents is the total number of sand total amount of sand removed. So we're going to have the initial value plus the amount of sand added plus minus the amount of sand removed. So this is going to be our final equation. Okay, now we can try part C. It asks us to find the rate at which the total amount of sand on the beach is changing at time t equals 4. So if you kind of think about that for a second, find the rate at which the total amount of sand on the beach is changing at time t equals 4. So it's changing. We don't necessarily know yet if it's increasing or decreasing, but we do know we have two different functions that represent two different rates: the rate at which sand is being added and the rate at which sand is being removed. So if we can combine those two functions and have the relationship between those two functions, we can find at which points the amount of sand is decreasing, at which points the amount of sand on the beach is increasing, and the rate at which the total amount of sand on the beach is changing at time t equals 4. So what we want to do is we want to take s of t, the amount of sand added. Well, first, actually, for the sake of the free response question and getting all the points, let's write y prime of t, because remember, y of t is the total number of cubic yards. So y prime is the rate at which the total number of cubic yards is changing, which we're trying to find. Y prime of t is equal to s of t, right, which is our rate that sand is added, minus r of t, which is the rate at which sand is removed. Because if we take all the sand added and subtract all the sand removed, we have the rate of change, the general rate of change of sand on the beach. So now we're going to plug in 4. We're going to go y of 4, or y prime of 4, sorry, equals s of 4 minus r of 4. And now what we're going to do with that is go to our calculator, and we can type this in. Here, let me clear this. So remember, s of t is our y2, so we're going to go alpha trace 2. Now we have y2 of 4 minus alpha trace y1, because that's our sand removal function, of 4, and then hit enter, and we get it's equal to, it keeps disappearing, it's equal to negative 1.909. Negative 1.909. And the question does not ask us to, the question C does not ask us to provide units. It just says find the rate at which the total amount of sand on the beach is changing. So we don't need to provide units. And this is our final answer, negative 1.909. So part D says for t is between 0 and 6, at what time t is the amount of sand on the beach a minimum? What is the minimum value? Justify your answers. So this last part is very calculator intensive. So what we can do here is go back to our y equals table or plot, and we have to type in a function, or type in the function for y, so that we can find where t is at a minimum. Because remember, our function y shows us where the amount of, or how much sand is on the beach at any given time. So if we want to find where the amount of sand is at a minimum, we need the function that shows us the amount of sand. So we're going to put y in for our y3. So remember, y is 2,500 plus parenthesis math 9. So the integral now from 0 to x of y2 first, right? The sand added with respect to x, and then close parentheses, minus math 9, 0 to t, or 0 to x in this case, of alpha trace y, or sorry, not y2, this time it's y1, with respect to x. So this is 2500 plus the total amount of sand added on 0 to x minus the total amount of sand removed on 0 to x. So now let's graph this. So our x window should be from 0 to 6, because it says from t is between 0 and 6, or for t is between 0 and 6. And to find, or to determine our y window, we can look at the function. So it starts at 2500, and we know that the rate sand is removed and the rate sand is added is about equal, just logically. If you're thinking about a beach, if they're trying to add sand to make up for the lost sand, the rates are probably about equal. So it's not going to probably change very much on this 0 to 6 interval. It's probably going to stay about the same, the amount of sand on the beach, that is. So let's make our y min 2450 and our y max 2550. So now we can click graph, and this takes kind of a while to graph because it's a complicated function. Okay, so it's done graphing. So now we need to find the minimum, right? The minimum amount of sand, because this is the graph for the amount of sand. So we can tell the minimum is right here, right? That's the lowest part in the graph, but we don't know what value that is. So what we need to do is click second trace, and then 2, so we can find, or no, that's not right. And then 3, so we can find the minimum. And now we go for our left bound limit. So let's just drag it as close to that point. Well, it doesn't necessarily need to be as close to that point as it can be, but we'll just drag it closer to that point. So right here is okay. Click enter. And now we need to go a little bit to the right of this point. So pull it to the right until we're just past that point. So that works. Click enter. And now we click enter a third time to guess. And it's going to think for a second, and then it's going to tell us that, boom, okay. So it told us that we have a minimum at t, or in this case x, but for the sake of the problem, t, equals 5.118. So we'll go t equals 5.118. And the minimum value, or the y value, is 2492. So y of t in this case is equal to 2492369. Or well, let's just round this since we rounded the other one. So we can do y of t in this case when t equals 5.118 is equal to 2492.370. So now we have to kind of write this in a more explanatory way and kind of justify our two answers. So we found the two answers. We found the minimum value and the amount when the amount of sand on the beach is a minimum. Now we just have to write it out and justify it. So here's how you can write it. On 0 to 6, the amount of sand on the beach is a minimum. On 0 to 6, the amount of sand on the beach is a minimum at t equals 5.118 since, so this is justifying our answer, since y prime of t equals 0, right? So at this point on y of t, the derivative is equal to 0. Therefore, it's a minimum. or maximum, but in this case a minimum. And then we'll do y of 5.118 is equal to 2492.370. Therefore, the minimum value of y of t on 0 to 6 is 2492.370. And in the question D, there's no mention of any units, so we don't have to worry about saying units. So that's the answer for the last part of the question. And thank you very much for watching. If you have any questions or video requests, I would be happy to look at those and make videos on them. So please comment and subscribe and like. Thanks.